prevent incidents where broken utility primary and grounded conductors send high voltage to service equipment, energizing neutrals and equipment grounds. Several measures should be taken. Firstly, reinforce the utility infrastructure. This involves increasing the strength and reliability of primary and grounded conductors to withstand potential stresses. Utilize underground or weather-resistant overhead lines to reduce vulnerability to environmental factors. Conduct regular inspections and maintenance to identify and address potential weaknesses. Secondly, enhance the grounding system. Ensure a robust grounding electrode system with multiple ground rods or other approved methods. Inspect and maintain grounding connections regularly to verify continuity and proper functioning. Consider using a surge protection device on the incoming service to mitigate potential voltage spikes. Thirdly, upgrade service equipment. Install surge protection devices on service panels to protect against power surges. Use ground fault circuit interrupters, GFCIs, and arc fault circuit interrupters of size to detect and isolate dangerous electrical faults. Upgrade to modern service equipment that meets current safety standards. Fourthly, focus on appliance and equipment safety. Regularly inspect and maintain electrical appliances and equipment, particularly those with exposed heating elements. Install smoke detectors and fire extinguishers in strategic locations. Unplug appliances and electronics during storms or prolonged power outages to minimize potential hazards. Fifthly, education and awareness are crucial. Educate homeowners and tenants about the importance of electrical safety and grounding. Promote awareness of the potential risks associated with broken utility lines and the need for immediate action. Encourage regular safety inspections and maintenance of electrical systems. Additional considerations include investigating the cause of the broken utility lines to determine if it was due to external factors such as falling trees or vehicle collisions or inadequate maintenance. Collaborate with the utility company to ensure proper repair and reinforcement of their infrastructure. Consider the use of a whole house surge protector to provide additional protection against voltage spikes. Regular electrical inspections by a qualified electrician can help identify and mitigate potential electrical hazards. Grounding is a critical safety measure in electrical systems, designed to provide a low impedance path for fault currents to return to the source, thereby tripping a circuit breaker or fuse and energizing the circuit. This prevents electrical shock hazards and minimizes the risk of fire. A properly installed and maintained grounding system is essential for the safe operation of electrical equipment and the protection of people. The grounding electrode system typically consists of ground rods, ground plates, or underground metallic water pipes that are bonded together to form a common ground point. The size and type of grounding electrode required depend on the size of the electrical service and the local electrical codes. Regular inspection and testing of the grounding system are necessary to ensure its effectiveness. This includes verifying the continuity of grounding conductors and measuring the ground resistance to ensure it is within acceptable limit. If the ground resistance is too high, additional ground rods may be required to improve the grounding system. Surge protection devices, SPDs, are designed to protect electrical equipment from voltage spikes and surges caused by lightning, utility switching, or other electrical disturbances. SPD work by diverting excess voltage to ground, preventing it from reaching sensitive electronic components. SPD are available in various types and sizes, depending on the application and the level of protection required. They can be installed at the service entrance, subpanels, or individual circuits. It is important to choose SPD that are appropriately rated for the electrical system and to install them according to the manufacturer's instructions. Ground fault circuit interrupters, GFCIs, are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs work by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference of more than a few milliamps between the two currents, the GFCI will trip, cutting off power to the circuit. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters (AFCIs) are designed to protect against fires caused by arc faults. An arc fault is an unintentional electrical discharge between two or more conductors. Arc faults can occur due to damaged or deteriorated wiring, loose connections, or faulty appliances. AFCIs work by detecting the unique characteristics of arc faults and tripping the circuit breaker. AFCIs are required in many areas of the home, particularly in bedrooms and living areas. Regular maintenance of electrical appliances and equipment is essential for preventing electrical hazards. This includes inspecting cords and plugs for damage, ensuring that appliances are properly grounded, and cleaning appliances regularly to remove dust and debris. Appliances with exposed heating elements, such as toasters and space heaters, should be used with caution and kept away from flammable materials. Smoke detectors and fire extinguishers are important safety devices that can help to prevent fires and protect lives. Smoke detectors should be installed on every level of the home and tested regularly to ensure they are functioning properly. Fire extinguishers should be readily accessible and homeowners should be trained in their proper use. Education and awareness are critical for promoting electrical safety. Homeowners and tenants should be educated about the potential risks associated with electricity and the importance of following safety precautions. This includes avoiding overloading circuits, using extension cords safely, and keeping electrical appliances away from water. Regular safety inspections of electrical systems can help to identify and mitigate potential hazards. These inspections should be performed by a qualified electrician who can assess the condition of the wiring, grounding system, and other electrical components. The National Electrical Code (NEC) provides comprehensive standards for the safe installation and maintenance of electrical systems. The NEC is updated every 3 years to reflect changes in technology and best practices. Electrical contractors and inspectors are required to follow the NEC to ensure that electrical systems are installed and maintained safely. Some specific recommendations include ensuring the service neutral is properly sized. Undersized neutrals can cause voltage imbalances and overheating, increasing the risk of fire. The size of the service neutral is determined by the calculated neutral load as specified in NEC. Grounding electrode conductor should be properly sized and connected. The grounding electrode conductor connects the service equipment to the grounding electrode system. It should be sized according to NEC Table 250.66 based on the size of the service entrance conductors. Bonding jumper should be used to bond all metallic parts of the electrical system together. This includes metal conduits, enclosures, and equipment frames. Bonding jumpers provide a low impedance path for fault currents, helping to ensure that circuit breakers and fuses will trip quickly in the event of a fault. Surge protection devices should be installed at the service entrance and at subpanels to protect against voltage spikes. SPD should be selected based on the voltage and current rating of the electrical system. Ground fault protection should be provided for equipment that is likely to be exposed to moisture or other hazards. Ground fault protection can be provided by GFCIs or ground fault relays. Arc fault circuit interrupters should be installed in branch circuits that serve bedrooms, living rooms, and other areas where arc faults are likely to occur. AFCIs can help to prevent fires caused by damaged or deteriorated wiring. Regular inspections of electrical systems should be performed by a qualified electrician to identify and correct any potential hazards. Inspection should include checking for loose connections, damaged wiring, and overloaded circuits. In addition to these technical measures, it is also important to promote electrical safety awareness among homeowners and tenants. This can be done through educational programs, public service announcements, and other outreach efforts. By taking these steps, it is possible to significantly reduce the risk of electrical hazards and protect people and property from harm. Remember to always consult with a qualified electrician for any electrical work to ensure it is done safely and in accordance with local codes. It's also worth noting that while a grounding electrode system is designed to handle fault currents and provide a path to ground, it's not designed to handle sustained high voltage from a broken utility line. The primary purpose of the grounding electrode system is to stabilize the voltage to earth during normal operation and to provide a low impedance path for fault currents to trip over current protection devices. The surge protector device helps divert excess voltage to ground, protecting your equipment. The GFCIs and FSIs also protect against electrical shock and arc fault.